Hi, I'm Ted Parks, and I am the owner of Teddy Bee Honey Company and also a Sheridan College alumni. I have installed 4 hives here on the Sheridan, 2 here in Oakville, and a couple of hives in Brampton at the campus there. And this whole initiative was brought on by the Sheridan College Student Union Association with Kyle Budge as the president, and my contact and liaison through all of this has been Dan Casey. Teddy Bee Honey Company is a boutique apiary, as I call it, running about 40 hives, and I think on my website I say pampered hives. And I also have a few other, corporate green roof hive hosting clients in the city of Toronto. The philosophy behind Teddy Bee Honey is that we manage the bees as holistically as possible. We don't use any harsh chemicals unless absolutely necessary for the survival of the hive or the bees. And fortunately, there's been a big movement towards more natural treatments for the bees and some of the pests that we now have to deal with. That has become a bit of an easier task than in years past. So on that note, let me maybe take you through one of the hives, and we can take it apart, and I can show you some of the differences of the bee casts, the drone, the queen, and the worker bees, and we can take a look into the hives right here behind us. Here I have my bee belt. I have a marker for marking the queen, although we shouldn't really need that today. I do have a queen cage in case I want to put the queen in a safe spot while I'm inspecting the hive. And then this is the hive tool. And this belt is actually the creation of a beekeeper that runs the University of Guelph Beekeeping Research Center, Honeybee Research Center. So it's a local made belt. The first thing we're going to do is put a little smoke to the hive. Just get this going a little better. The purpose of the smoke is twofold. One is when the bees smell the smoke, they're thinking forest fire. So they will go down into the hive and start feeding on honey. They'll gorge themselves on honey to make sure they have as much energy as possible if they have to flee. The other thing it does is that it masks the pheromone of the hive. So if a bee gets upset, then it will not be able to signal to the other bees that I'm here, and that way I won't get stung as much. The smoker is, you can use a variety of different fuels for your smoker. I mean, I'm using wood chips or wood shavings. I mean, there's some commercially available pellets, as well as, some people use pine needles, burlap, but there's a variety of things. As long as it's natural or made specifically for bees, you don't want to just throw old garbage or anything like that in there, of course. So what we have here is, in this configuration, we have the bottom box is what we call the brood box. That's where the queen is housed, and the queen's laying, and all the young bees are being raised in this bottom box. These other 2 boxes, because we're here in mid-season, are what we call the honey supers. So these 2 boxes are what the bees are actually moving and storing the honey to. So we'll have a look in there first. So the thing with the bees is just to be sort of slow and methodical, not any big banging moments and what have you. So I'll just put a little smoke on the top here. We'll pull out one of these frames here, and I can show you Sheridan College's student union's first honey harvest, or honey. Okay, so what we have here, this is actually a great frame. So this is all honey. So the bees, they collect the nectar. They actually have 2 stomachs, one for food and one for nectar. And they come back from foraging and they regurgitate the nectar along with some enzymes and stuff from their stomach that creates the honey. Here we'll see this is all capped honey. So that's a wax capping that they put on. And they don't do that until the honey is at the exact proper moisture content. So if there's too much moisture in the honey, it will ferment and go bad. But the bees know exactly when the honey gets to that proper moisture content, and then they cap it, at which point then it lasts forever. Honey never goes bad. So they got a little bit of work to do on this one, but it's nice that they've started capping With this humid weather, it sometimes takes them a little longer to get the honey all capped. Go a little further in. So these are heavy and they sometimes get welded together with wax and what have you. You'll also notice that I'm not wearing a bee suit. When the weather's nice like today, the bees are pretty happy and content to be out foraging. As long as I don't do anything too crazy, they don't feel threatened. And they're not necessarily or usually aggressive by nature. The reason I'm scraping the tops on this is that they build wax and they weld the boxes together. So this is an opportunity for me is to clean the top bars off so that the next time I come I don't have to fight the boxes all welded together again. Because the bees, they will fill every single available space with wax and honey. So now we're gonna pry this off. So this gray thing that we're revealing here is what we call a queen excluder. So what it is, the queen is about twice as large as a worker bee. So this excluder prevents the queen from being able to travel up into the boxes where we're collecting the honey. Because if she was allowed to come up into these boxes, she'd be laying eggs and brood in our honey, which makes it just a lot more difficult to harvest. So we put the excluder on to contain the queen to this bottom part of the hive. Okay, so this is where the queen lays all the eggs and raises all the brood. Although this was a new hive in the spring, which was actually just 4 frames with bees on it, they have now built themselves out to be all 10 frames. There's probably roughly 50,000 bees as part of this colony right now, with a large percentage of them out foraging on the flowers and stuff. So we just have to be really careful as we pull this first frame out, especially that we don't accidentally crush the queen. So on this frame what we have, which is actually, we got a little bit of everything, which is kind of almost an ideal frame. Here on the very corners we have a little bit of honey, which is stored there. Then working towards the center we have pollen. You can see the different colors and the shininess of the pollen that's in those frames here. And then in the very center, the light brown cells that we see are actually, that's brood. Those are eggs and larvae and pupa as in different stages in that frame. You can see it all. Okay, so you look at the brood here on the back. That's beautiful. Yeah, as a beekeeper, this is a real nice frame, and this is on the outside. As we work through the hive, we're going to see all kinds. Okay, so I'm going to set this frame here gently so we have some room to work in the hive. So in Ontario, we have about 400 species of native bees, and actually the European honeybee is not one of them. Actually, these honeybees are not native to North America. They were actually brought over from Europe in the 17th century. I mean, there are a lot of misconceptions about honeybees in particular. I mean, a lot of people don't understand the difference between the honeybee and the wasps and stuff. For example, the honeybee is not interested in your barbecue. If there's bees buzzing around your outdoor dinner, then it's most likely a wasp. It's not a honeybee. Honeybees are not necessarily aggressive by nature. If they feel threatened, they will sting you, but that is kind of the extent of it. As a beekeeper, this is a fantastic frame. I mean, for mid-season, to have it wall-to-wall brood like this, the queen is very strong, laying well. It's a nice even brood pattern. Well, the brood is actually the capped bee cells. Behind every one of these cells that's capped in the tan color will be a new bee. So this hive, the population of this hive is going to continue to be very, very strong going forward through the summer. And given the fact that the lifespan of a honeybee during the summer is about 4 weeks, they literally work themselves to death in 4 weeks. Wow. And during that lifespan, they will produce 1/12 of a teaspoon of honey. Oh, wow. So the jar of honey you have in your cupboard is a product of probably about 500 bees and their entire life. So this is a very healthy, thriving hive at the moment. The one thing as a beekeeper that we do have to, fight against is a parasite called the Varroa Mite, which has been attributed to, most of the decline of the honeybees. It's a parasite that attaches itself to the backs of the bees, feeds off their hemoglobin and their fat cells, and it compromises their immune system. Once that immune system has been compromised, then the bees are susceptible to multiple other diseases. So at any given point in the season, the bees will always have the idea that if something happens to the queen, that they can nurture a new queen fairly quickly. So here on this frame, we actually have some queen cells. So here you can see that the queen cells here, these two right here, they're raised cells pointing downwards versus the flat cells of the larva for the worker bees. And actually this frame kind of shows, I'll just have to hold it a little more like this. So we have queen cells here, which are, stick out and they're facing downward. And then here, for example, this is just normal brood female worker bee cells. And then here, this lumpy brood here, those are drone cells. And again, the drones are larger bees, so they require a larger cell. Well, actually, we have a bee emerging as we speak right here. See right there where my thumb is?
Yes.
So that,
focus on that for a minute.
yeah, so here we have a couple of worker bees emerging from the cells. So they will chew their way out of the wax capping that's on their cell once they're ready to emerge. And a new worker bee, we can see them in the hive because they're a little fuzzier. They're born with a fair amount of little fuzzy fur and stuff. So, and actually, when they're first born like this, they do have a stinger, but it's not developed enough to be able to actually sting. So the majority of the hive are worker bees. They're all females, and they look after the hive in the sense of that they do all the housework, the cleaning. They forage for all the nectar and pollen. They nurture the queen. They feed the queen, and produce all the honey and the wax. The drones are the male bees. Don't do much. Their only sole purpose is to mate with a virgin queen. So only a small percentage of the bees in the hive are drones. They're usually, we'll see one here in a second, they're quite a lot larger than the worker bees. They do not sting. They basically don't really have any function inside the hive except for to propagate with queens. And the queen, a virgin queen, makes one or two mating flights and mates with multiple drones during those flights, and then she is then mated for life. She will never fly or mate again. So as the queen ages inside the hive, and the hive is sort of held together with pheromones from the queen, once the queen starts to age or has any kind of health issues, that pheromone level starts to decline. And that will signal the hive to plan succession and start nurturing a new queen. And at that point, they take advantage of those queen cells that we just looked at. And as a new queen is born, the old queen and the new queen will literally fight it out to the death. There's actually only one queen in each hive. The entire health of the hive is dictated by the queen from a laying standpoint and population wise, and as we can see here with the amount of brood that we have and eggs and larvae, that this queen is actually doing very well, and which is to be expected because this was a new queen this year. Well, a queen can live about 4 years successfully. During the mating, the queen with the drone, she stores millions of sperm in her abdomen, and that's why she's quite a lot larger than the rest of the bees. And those millions of sperm are what fertilize. So the queen mates once and has enough sperm stored to continue laying 2,000 eggs a day during the peak of summer, for 3 or 4 years. The gestation period is different for each of the different bees. A queen bee is actually reared the quickest. It's 16 days from egg to queen. And a worker bee is 21 days, 23 or 4 days for a drone. Every 4 weeks during the summer, the entire population of the hive rolls over once because the worker bees, work themselves to death in 4 weeks. The queen has to replace those 50,000 bees every 4 weeks. So for the queen, the laying process peaks around the summer solstice, and then the opposite is true, that the fewest, the queen lays virtually nothing at the winter solstice. The big issue for winter survival is not necessarily the cold. They can withstand the cold quite well. They cluster really tight together, and they can actually keep the center of the hive at about 35 degrees year round. As the days get shorter, the queen recognizes the fact that winter is coming, and she'll start laying fewer and fewer eggs. And with that, the population starts to decline, and the bees will start storing all the space that was normally for brood like this. They will store honey in it, and that's their nutrients for the winter. But it takes an extraordinary amount of energy for them to do that, and that energy comes from the honey that they feed on and that's stored in the hive. So as a beekeeper, we have to manage that balance between the amount of honey that we take off, when we take this honey off, and how much we leave for the hive to survive the winter with. The thing is, as beekeepers, we do everything we can to keep the hive as healthy and as sustainable as possible. There's no reason a beekeeper would want to risk losing a hive through winter by being greedy and taking too much honey. Usually when that happens, it's by mistake or a situation arose that was sort of unpredicted, like a very early fall turnaround of weather that may take us by surprise, as Mother Nature is so capable of doing. So come winter, this hive is reduced to just this box. These other boxes are not part of the winter hive. And we do wrap them just to help them maintain the heat and save their heat. So we'll put a bit of insulation under the lid, and we put a wrap around the hive just to protect it from the weather and the elements a little bit. And that's all we really do. We don't have to do a lot more than that. So it's a pretty simple process. Originally, I was attracted to beekeeping because I read an article about colony collapse disorder. I think it was in National Geographic, and in the very beginning they had no idea what was causing an entire healthy hive like this to be here one day, and for the beekeeper to come back a couple of days later and the box would be nearly empty and not a sign of any of the dead bees. And there was all kinds of crazy theories in the beginning about cell towers, and it's taken a long time for them to discover that in all likelihood those scenarios were probably pesticide poisoning. But on top of that pesticide poisoning, the biggest threat to bees and the population is the Varroa destructor, the Varroa Mite, and the immune compromise that's created by those. And so as a beekeeper with honeybees, we do have a lot greater loss. There's a lot more work to keeping the bees healthy than ever before, but we are managing the colonies much differently now. And with that, we've been quite a bit more successful than say a decade ago. The bigger issue is the wild bees, the native bees, because they are also suffering from many of the same issues of climate change and different strains of disease that the honeybees are suffering from, but without the management or the benefit of the management. So, bumblebees in particular, with climate change and habitat loss, there's over 400 different species of native bees in Ontario, and they're all out there fending for themselves. So when I first started keeping bees, it was really just to do my part to have some bees in my backyard and the benefit of the bees pollinating the gardens and stuff. So one of the things that people can do at home is plant pollinator-friendly plants and flowers, as well as for the native bees, if there's an area of their backyard that they can let go a little bit wild, that's also a great advantage. But some of the bee-friendly or pollinator-friendly plants, are lavender, cornflowers, sunflowers, phlox. I know most people think them of weeds, but thistles. There's quite a variety, and even your local nursery can certainly point you in the right direction. Certain herbs like sage and stuff, the bees are attracted to as well. So there are things that you can do without actually physically keeping bees in your backyard. Thanks for joining me in this presentation. It's always nice to be able to explain some of the beekeeping techniques and offer a little more understanding of honeybees. They're quite often misunderstood and the importance of them in the ecosystem. So it's really great that the Sheridan College Student Union has taken this initiative and brought the bees to campus. So if you have any questions, I'm available for any thing you might want to ask in the next short while. Thanks.